Howdy, this is your friendly neighborhood physics teacher here, and we're going to talk about your PhET simulation. And the first thing is you're going to go to your Schoology, and when you click on your PhET simulation, this is another one that you're going to have to force to work a little bit. So when you click on it, you'll go back to the screen that we had, and it'll say that your flash doesn't work. So go ahead and remember, push the little button to push it to the whole entire thing. Now, mine pops up because it's working, but you see this little lock there? If you go there, it probably means your flash is blocked. And yes, we've unblocked it for other simulations. We pretty much have to unblock it almost every single day, myself included, and you want to click allow. And so it will work. And it'll ask you to reload. Sure, you can reload. Now, so this is your PhET simulation. There we go. So a couple of things. Now this is in the Schoology assignment, but you want to make sure you're in principal rays. Your curvature is 0.8. Your refraction index, it's just saying how thick your lens is 1.53. Your diameter is 0.8, and you want to do show virtual image, and you want to do ruler. And you can sit here and move your object. Now, you can sit there and change your object. Now, you can see how there's different heights there. I would stick with the pencil. Like, while you're playing with it, you can do it, but when you're actually figuring out the information, stick with the pencil, because that's the one that we used to calculate. And if you notice, like, the heights are a little bit different, so your calculation, your measuring would be a little off. Now, this X is your focal point. So when I sit there and measure, you're just going to drag your meter stick and, well, it's not a meter stick, but your ruler, and see that what it's measured at. If you need to pull it down a little bit, and notice that these are in 2, so 2, 4, 6, 8, 10, so that's 10 centimeters, 20 centimeters. So yeah, so the big lines are in 10s, the little lines are in by 2s. And you just sit there and measure that. When you go to measure your object length, you want to put this corner on the edge, and you measure from corner to there's a line in your lens. Now, this is a convex lens. We will do a concave lens. We'll actually have to use a different simulation for that. And so remember, this is your object. Over here is your image, and you'll just measure. Now, it'll ask for your height also. Sadly enough, I did not figure out a way to rotate the ruler to make it vertical. So my suggestion would be to take a little piece of paper, put like where the bottom part, and use this side, because that's the side I used. So put a line here, rotate the piece of paper, and use this ruler. No, you cannot grab another ruler, because the rulers do not add up. Like this ruler, that actually isn't 20 centimeters and stuff, so it's not accurate. But we'll keep it accurate for this simulation. So yeah, so just get a piece of paper and mark it, and then measure out, and you'll get really close. It's a drop-down menu, so as long as you get close. Now remember, this side's virtual, this side's real. So anything on this side should be negative. Anything on this side should be positive. And now, when you sit here, you can only move your object. Now, there will be a point in time when you get too big that you can't really measure. There is an option for you to, it's off the screen. I can't measure it. So I think you only use that 2 or 3 times, I believe. 2 or 3 times. But you will use that a couple of times. And I'll give you a hint. When it says pick a distance that is greater than your double focal point, go ahead and just use the whole entire length of your ruler here. So that'd be a full 200 centimeters. And then it'll ask you, so there'll be a few things that are like a little, I guess, not as detailed on where to put it. So yeah, they'll just look at your drop-down menu. So when it's asking for greater than your 2F, use 200. When it's saying between your 2F and your focal point, I believe I used 30 for that, 130. Yes, I used 130 for that. So you could actually at least get the distance of your object. And then for between your focal point and your lens, I used 38 centimeters. So just little helpful hints on that one. And just remember, anything that's virtual is negative, anything that's real is positive. And then anything that's upright is positive, anything that's inverted is negative. So this would be a real inverted image. Now your next one you'll be using is part of a physics classroom simulation. Go ahead, and I know it's really hard to see, but you can go ahead and make it big. And this one's pretty simple. You literally just put your object at to focal point. Your focal point is 20, so make sure this says 40 here. And you just write down the information. And then you sit here and you're going to put it at focal point. Make sure it does say 20. You have to sit there and play with it a little bit and write down that information. And you want to make sure you're in the divergent lens. You are dealing with a concave lens. So this one's pretty straightforward, and you'll be able to answer questions like that. If you have any questions, please ask Miss Heath or Miss Verona. They'll gladly help. Hopefully you have a wonderful day. Bye.